Okay, for step 3, we're going to analyze f double prime of x. So this is f prime, so we're just going to take the derivative of this. So I started it out for you. So 5 times negative 0.2 e to the negative 0.2 x minus x times the derivative of e to the negative 0.2 x plus e to the negative 0.2 x times the derivative of x. And after all of that, you come down to here, and this is your final answer. This is f double prime of x, e to the negative 0.2, this should be an x right here, x times 0.2x minus 2. So, now, where is f double prime of x equal to 0 or undefined? So, as I said before, this can't be 0. So you have to take this right here and set it equal to 0. And from that, you get x equals 10, which is the critical value. So, make our sign chart, put 10 right there. I plugged in 0 on the left side, and it ended up being negative, so that means it's concave down from negative infinity to 0. And for this one, I plugged in 12 and got a positive number, so that means it's concave up from 10 to infinity. So, in order to find, this is also a point of inflection. So in order to find that, you plug 10 back into the original equation, and once you do that, you get 6.77. So your point of inflection is 10, 6.77. Okay, for step 4, we're gonna find the graph. So this is all the stuff that we found from step 1 to step 3. We found that the domain is negative infinity to infinity. Both the x and y intercept are 0, 0. Asymptotes, there is no vertical asymptotes, but there is a horizontal asymptote at y equals 0. We have a max of 5, 9.2, increasing from negative infinity to 5, decreasing from 5 to infinity. There's a point of inflection at 10 and 6.77. It's concave up from 10 to infinity, and it's concave down from negative infinity to 10. So as we graph, this is the graph. So I started right here. Well, actually, I started right here. Draw the y equals 0 as horizontal asymptote, and there was a x and y intercept of 0, 0. So that's that point. This is the local max right here, which is 5 and 9.2. The point of inflection is right here, which is 10 and 6.77. And so we know that the graph is concave down from negative infinity to 10 and concave up from 10 to infinity. So this is our graph.
Okay, so next we're going to do an application problem. If x cell phones are produced in one day, the cost per day is C of x equals 0.8x squared plus 20x plus 8,000, and the average cost per unit is C of x divided by x. So A, we have to analyze and sketch the average cost function. B, sketch the marginal cost function. C, sketch both A and B on the same graph. And D, find the minimum average cost. Okay, for step 2, we're going to analyze C bar prime of x, and just to get C bar of x, you take the C of x and put it over x, and then you just divide out the x's, and then you get 0.8x squared plus 20 plus 8,000, 8x to the negative 1 power. So then you want to find c bar prime of x, and all you do is take the derivative and you get 0.8x minus 8,000x to the negative 2, or 0.8x minus 8,000 over x squared. They're the same thing. So our question is, where is c of x equal to 0 or undefined? So we're going to go over here, follow the arrow. So all you have to do is set that equation equal to 0, and we will find that that equation is undefined at x equals 0, but 0 is not in the domain. Our domain is x is greater than 0. So therefore it is undefined at 0. So let's follow the next arrow. So we are going to take 0.8x squared minus 8,000 and set it equal to 0, and we get x is equal to plus or minus 100, which is the critical values, but negatives are not defined in this equation. So therefore x is equal to 100 is the only thing that is defined. So that is our critical value. So we're going to follow this arrow to the sign chart. So the sign chart has the 100 right there, and we are going to plug in numbers from the left and the right. So I plugged in 25 into the into c bar prime of x and got a negative number. So therefore it is decreasing from 0 to 100, and it's 0 because x is not defined under 0 or at 0. So the number that I took to the right is 125 and got a positive number, and it's increasing from 100 to infinity. Therefore, the local min is 100 and 180, because I took 100 and plugged it into the original equation and got 180. Okay, for step 3, we're going to analyze c bar double prime of x. And here the equation right there, that is c bar prime of x. So you just take the derivative of that, and then you get 16,000 x to the negative third, which also is 16,000 over x to the third. So where is c bar double prime of x equal to 0 or undefined? It is undefined at x equals 0, but it's not in the domain, so it doesn't really matter. This is because c double prime of x is always going to be positive, which means that it is concave up from 0 to infinity, and there are no points of inflection. Okay, last step, step 4, the graph. First, the marginal cost function is only the derivative of c of x. So I did that right here. C prime of x is equal to 0.16x plus 20. And so that is also the marginal cost function. So in order to graph, this is what we need. We have the minimum, which is 100, and at 180, it's decreasing from 0 to 100, and it's increasing from 100 to infinity. So that's just a basic parabola. And here's my graph. So the parabola is right there, and then I graph the marginal cost functions, 0.16x plus 20. It is that line right here, that straight line. And the minimum is right there, 100 and 180. So that's the marginal cost function, as I said before. And we have our asymptotes, our vertical asymptote and the horizontal asymptote. And so to find the minimum cost, the minimum average cost, all you had to do was see what the y value was for the minimum, because that is the lowest that the problem will go. So the minimum average cost is 180, since 100 is the minimum x value. So that is our application problem.